Part 3. The human scale: culture, teams, and reliability.
Shifting focus now.
Yeah, let's talk about the human element, because software is built by people, ultimately for people. Technology alone doesn't guarantee success. Often the way teams are structured, the culture they operate in, the processes they follow, those are the determining factors.
Couldn't agree more. The human systems are critical.
And these aspects are becoming even more critical as we start blending human intelligence with machine intelligence in our teams. Our first book in this section is by Intel's legendary CEO, Andy Grove, High Output Management.
Grove, a management classic, especially for engineers.
It's such a practical guide to management. His core idea is that a manager's output isn't their individual work, but the combined output of their team and the neighboring organizations they influence.
And what's so insightful here is its engineering-centric, very output-oriented approach in an AI-driven world where individual developer productivity gets highly augmented.
Yeah, the potential is huge.
The manager's role really shifts. It moves away from just tracking lines of code or tasks completed towards maximizing the leverage output of a combined human AI team. Grove's concept of managerial leverage is absolutely core here. A high leverage activity is one that generates high team output from relatively low managerial input or effort.
Give me an example.
Okay, teaching your team how to write effective prompts for an AI coding assistant, that's extremely high leverage. Or teaching them how to critically review AI-generated code based on principles. Also very high leverage. His principle of task-relevant maturity, or TRM, also applies perfectly. An AI might have high TRM for generating boilerplate code, it's mature at that task. But it has very low TRM for understanding nuanced business context or doing creative, out-of-the-box problem solving. The manager needs to assign tasks accordingly.
But I hear the criticism that a book from the 1980s about hardware manufacturing is outdated or irrelevant to modern software development. How do you respond to that?
I think that's a superficial reading, frankly. While the specific examples certainly differ, he talks about making breakfast, not deploying code. The underlying principles of process, leverage, output, measurement, they are timeless.
Right.
Software development, especially when you do it at scale, is fundamentally a production process. And the AI makes this a relevant argument. It's flawed. AI tools are force multipliers. They dramatically increase the potential leverage a good manager can apply. Grove's book is the definitive guide on how to think about and apply that leverage effectively.
So how would a manager apply this day to day?
Okay, consider team one-on-one meetings. An engineer mentions they're spending hours on repetitive debugging tasks. The manager, thinking in terms of managerial leverage, might suggest, hey, why don't you spend maybe 4 hours this week researching an AI-powered debugging tool, see if it could help. They frame it as an investment. If you spend 4 hours now exploring this, you could potentially save yourself and maybe others on the team 4 hours every week going forward.
That's leverage.
Exactly. The manager sets a clear output for that task. Deliver a demo and a recommendation next week. That single action leverages the manager's time to potentially increase the whole team's productivity. You can also use AI leverage to shift left, championing the adoption of AI-powered static analysis or code review tools to catch bugs earlier in the development cycle, saving time and effort later.
For any engineer who's aspiring to management, this feels like arguably the most important book they could read.
I'd agree. It's incredibly practical.
It provides such a clear, logical framework for thinking like an effective manager. In an AI-driven industry, the ultimate value of management is in designing and optimizing the system in which the work gets done.
Precisely.
You can use these principles to systematically increase team productivity, justify investments with data, and build high-performing, motivated teams where top talent, augmented by AI, can really thrive.
That's the goal.
Next up, Jim Collins' How the Mighty Fall, and why some companies never give in. This one explores why great, successful companies often decline and sometimes ultimately fail.
A sobering read, but essential.
He identifies 5 stages of decline, arguing it's usually self-inflicted, and that recovery is possible if you catch it before the final, irreversible stage 5.
And this book serves as such a crucial cautionary tale, especially today, as AI seems to be accelerating both the rise and the potential fall of companies. The pace is just incredible.
How do the stages apply?
Well, the 5 stages provide a diagnostic toolkit for leaders, but also for individual contributors. For instance, stage 1 is hubris born of success. This can easily strike a company that has a big AI breakthrough. They get arrogant, they stop listening, they stop learning.
Seen it happen.
Stage 2 is the undisciplined pursuit of more. Maybe fueled by AI hype, a company starts leaping into new domains where they have no deep understanding just because they can use AI there. Stage 3 is denial of risk and peril. This is when leaders start dismissing negative data, maybe about AI model performance limitations or ethical concerns, blaming external factors instead of facing internal flaws.
That sounds familiar.
Stage 4 is grasping for salvation. This is where a company in trouble lunges for a silver bullet, like a radical, unproven AI pivot, instead of returning to the disciplined hard work that made them successful in the first place.
I've heard the criticism, though, that this book is only really for CEOs or top executives. But aren't the signs of decline often visible much lower down, maybe to frontline engineers, even if they aren't leading the company?
Absolutely. Those signs often manifest first as things like mounting technical debt that leadership ignores, or maybe engineers raising concerns about AI reliability or safety that get brushed aside.
Right.
And the whole AI changes everything narrative. It's a dangerous fallacy here. AI is powerful, yes, but it doesn't make a company immune to arrogance, lack of discipline, or denial. In fact, AI's complexity and its sometimes black box nature can actually make it easier for leaders to fall into denial, blaming the AI itself instead of flawed strategy or inadequate human oversight.
So how can an engineer use this framework?
Okay, imagine a senior engineer dismisses a junior engineer's valid concern about the long-term maintenance cost of some complex AI-generated code, maybe saying, we're the best, we'll figure it out later. You, being familiar with Collins, recognize that as potential stage 1 hubris. You could then try to reframe the conversation to be more disciplined. Okay, but is this added complexity truly worth the potential performance gain? Let's apply our skills now to find a simpler, more maintainable design.
Challenging the hubris with data or principles.
Exactly. Or if leadership suddenly announces a splashy new AI initiative while the core product is struggling with bugs and reliability issues, you might identify that as potential stage 2 undisciplined pursuit. You can then ask clarifying, data-driven questions about resource allocation, staffing, and validation plans for this new venture.
Understanding organizational decline provides a powerful strategic perspective, even for individual contributors.
Yeah.
It allows you to identify healthy versus unhealthy environments, to become a voice of reason within your team, challenging hubris with data and discipline, maybe even help lead turnarounds if things go wrong.
Yeah.
In an industry with such rapid boom and bust cycles, especially around AI, recognizing these timeless patterns of success and failure is a profound strategic advantage for your career.
Knowing when to stay, when to go, how to influence, it's critical.
Up next, Clayton Christensen's classic, The Innovator's Dilemma. When new technologies cause great firms to fail.
Required reading for anyone in tech, I think.
It introduces the concept of disruptive innovation, arguing that great, well-managed companies often fail precisely because they do everything right for their existing profitable customers, which makes them vulnerable to initially inferior but eventually revolutionary new technologies.
And what's truly fascinating here is that AI isn't just one single technology. It feels like a catalyst for waves and waves of disruption across countless industries simultaneously.
Yeah, it's everywhere.
This book gives you essential mental models to navigate this chaos. It explains why your obviously better AI feature might get rejected by your current big customers, maybe because it doesn't serve their existing needs or workflows. And conversely, why a seemingly toy AI application from a tiny startup could eventually upend your entire industry.
Right.
It clearly differentiates sustaining innovation, which is making existing products better for existing customers, something large companies usually excel at, from disruptive innovation. Disruptive innovation often creates entirely new markets, frequently starting with simpler, cheaper, maybe good enough AI tools that initially look inferior but improve incredibly rapidly.
Now, a common misconception is just using the word disruptive as a synonym for any successful new technology. But Christensen's theory is much more specific than that, isn't it?
It is very specific. It's not just about being better, it's about being different, often simpler or cheaper, and serving an overlooked or new market segment initially.
And what about the idea that AI changes everything and somehow invalidates his dilemma? Does it?
Not at all. If anything, it makes the dilemma more acute, more dangerous. A large incumbent company might focus enormous resources on building massive, expensive foundation models, a form of sustaining innovation, making their existing AI capabilities better.
Okay.
Meanwhile, a nimble startup might create a small, highly specialized AI model that solves one niche problem incredibly well, maybe for a market the big guys ignore. That could be the disruptive wedge.
So how do you apply this day to day as an engineer or maybe a product manager?
Okay, imagine you're proposing a simple, maybe slightly rough AI-powered code analysis tool, perhaps for a niche programming language. Management might reject it, saying it's too small or it's not as powerful as our existing enterprise solution.
Classic big company response.
Right. But you, recognizing the innovator's dilemma, could reframe it. Look, this isn't meant to compete head on. This is potentially a disruptive innovation targeting an underserved market of developers using this niche language. Let's create a small, autonomous team to test this hypothesis. The goal isn't immediate revenue, it's learning about a potentially new, growing developer segment.
Thinking differently about the metrics and goals.
Exactly. Or when you're evaluating new open source AI tools, you wouldn't just dismiss the ones that seem inferior today. Instead, you'd ask Christensen's questions. Does this enable new users who couldn't use the complex tools before? Is it significantly simpler or cheaper? Does it have a trajectory of rapid improvement that could make it dominant tomorrow?
Understanding the innovator's dilemma really transforms you from just a technologist into a strategist.
It gives you that strategic lens.
It equips you to effectively champion innovative projects within a larger organization, or maybe even to recognize opportunities to start your own company, providing a clearer roadmap for leveraging disruptive AI innovations.
Yeah.
This knowledge is absolutely essential for technical leadership roles, where evaluating emerging technologies and guiding long-term strategy is, well, pretty much the whole job.
It's table stakes at that level.
Okay, to close out part 3, we have Ben Horowitz's The Hard Thing About Hard Things. Building a business when there are no easy answers.
The brutally honest one. No punches pulled.
Exactly. It's this incredibly raw guide to the messy, painful, difficult challenges of running a startup, focusing heavily on what he calls the struggle and the need to make high-stakes decisions with incomplete, often ambiguous information.
And what makes this book so powerful, I think, is its unflinching focus on the psychological and emotional challenges of leadership. These are universal, but they often feel amplified in the incredibly fast-paced, high-pressure world of AI startups.
Yeah, the stakes feel high.
Horowitz's vivid description of the struggle, that feeling of self-doubt, maybe even despair that almost every founder or leader faces at some point, it's deeply validating, especially when a key AI model fails spectacularly or maybe funding suddenly runs out. His concept of peacetime CEO versus wartime CEO is also critical for the volatile AI industry. Knowing when to shift your leadership style from collaborative and consensus-driven peacetime to decisive command and control, wartime, is a crucial survival skill. And his principle of taking care of people, products, and profits in that order, that's paramount in a fiercely competitive AI talent market where people are your most valuable asset.
Now, a common misconception might be that this book is only for Silicon Valley CEOs building unicorns. But I'd argue the hard things, like giving really difficult feedback or managing underperformers or making painful trade-offs, those exist at every level of an organization, don't they?
Absolutely. They're universal leadership challenges.
And it's also sometimes criticized because it offers no simple formula, no easy answers.
But that's the entire point. There is no formula for the truly hard problems. Its value lies in providing a framework, shared experiences, and mental models for thinking through these incredibly difficult context-dependent decisions.
So how does this apply in daily engineering leadership?
Okay, imagine a key AI experiment fails badly, and team morale just plummets. You, as the leader, are now in the struggle, applying Horowitz's advice. First, tell it like it is. Address the team transparently. Okay, folks, the model failed. This is hard. That's exactly why we're the ones who need to solve it. Honesty builds trust.
Right.
Second, focus on the road, not the wall. Direct the team's energy away from blame or despair towards finding solutions. Maybe form specific task forces to investigate different aspects of the failure. And third, critically, manage your own psychology. You need to project calm and confidence to the team, even if you're churning inside. But find a trusted mentor, peer, or coach you can talk to honestly about your own struggles. Don't try to carry it all alone.
That's crucial.
And when hiring for your AI team, you'd follow his advice to hire for strength, not for the absence of weakness. Look for exceptional abilities in key areas rather than just well-roundedness.
For any technical professional who's aspiring to leadership in the AI space, this book feels essential.
Absolutely essential.
While AI can certainly help solve technical challenges, it cannot navigate the complex emotional and psychological landscape of leading a team through intense uncertainty and pressure.
No way.
Mastering these principles builds resilience, develops courageous decision-making, and helps create a high-performing culture where people feel safe to take risks. It transforms a great technologist into a great leader, a role that requires immense courage and emotional fortitude that AI simply cannot replicate.
It's the human element amplified.
Okay,